Good evening, students. In the morning class, we discussed about actuators, isn't it? Actuators. So, in any basic control system, we have a controller, process, and feedback element. So, if you open the controller, you can see the three main blocks. The first block is signal converter. Second one is actuator. The third one is final control element. Final control element. So, final control element. Now we are going to discuss about this final control element. Final control element is nothing but a control valve. Nothing but a control valve. So what is the basic difference between the actuator and final control, or actuator and a control valve? For actuator is a mechanism, is action needed for the a control valve. For the control valve, right? The control valve is a device, see, I am writing here. A valve is a device that regulates the flow of fluid. The fluid may be gas, sometimes liquid, sometimes fluidized solids or slurries, sometimes vapors, sometimes vapors. So the valve will regulate all these fluids by opening or closing, or sometimes partially obstructing various passageways. So this is called a control valve. So who can open and who can close this control valve? We need a mechanism that is called actuator. That means this is the main importance of the control valve. Actually, valves are technically five fittings. In an open valve, fluid flows in a direction from high pressure to lower pressure. This is what happening in this right. See, in this why we need to use this control valve? Basically, how with this control valve, we are able to control the flow rate of the liquid. So there should be some relation between and flow rate and sometimes stem position. The stem position nothing but for opening and closing we need some stems which are available in the control valve. So based upon the stem position, we can expect whether it is opened or not. If stem occupies complete area of the area within the wall, we can assume that it is closed. If stem is rotated in such a way that we can expect some opening position. So based upon the stem position, we can expect that whether it is open or closed. So control valves basically includes stems. Based upon the stem position, we are expecting flow or flow rate through the opening of the control valve. So the control valves basically that depends on stem and flow rate. That means if stem position is very low, we can get low flow rate. If stem position is high, we can get maximum flow. అంతే కదా, ఇప్పుడు ఓపెనింగ్ తక్కువ ఫ్లో వస్తాయి, ఓపెనింగ్ ఎక్కువ ఫ్లో వస్తాయి. సో ఓపెనింగ్ తక్కువ ఎక్కువ ఎలా తెలుస్తుంది? బేస్ అపాన్ ద స్టెమ్ పొజిషన్. So that's about the main importance of the control valve, that depends upon the stem position as well as flow rate. And basically, as per the syllabus, we have different types of control valves. Control valves, as per your requirement, as per the process industry, if it is a chemical process or if it is industrial process, there are number of control valves, number of sizes also, number of shapes also. I will show at the end of this class. So there are different shapes and different sizes, different stems, different techniques, mechanisms we needed for operating as a control valve. But as per syllabus, we have three basic control valves. So there are three basic types of control valves whose relationship between stem position and flow rate. That is important. Always remember, for any control valve, what is a control valve? It controls the fluid rate. It controls the fluid. So when we allow the fluid through the control valve, it depends upon the stem position. Stem position. That's the meaning of this. So control valve whose relationship between stem position and flow rate. So there are three types of control valves. The first one is quick opening control valve. Second one, linear control valve. Lastly, equal percentage control valve. Equal percentage control valve. So what is the meaning of quick opening control valve? Generally, if you take any control valve, the main intention or purpose is it allows the fluid. It allows the flow means liquid flow through this. Otherwise, it controls the liquid flow. It controls the liquid flow. So generally, you know that if you go and get some water from the tap, what happens? You have to open it. Then only you can get the water. If you operate in another direction, no water. Basically, so how to get water inlet and water in and out based upon the position of the control valve, stem position. So in this quick opening control valve, why it's named as quick opening means see the characteristics. We are drawing the three characteristics of the three types of controllers. See the relation between stem position and flow rate. The graph is drawn for stem position versus flow rate. Stem position on the x-axis, flow rate is on the y-axis. So observe the first graph. This first graph, observe this graph refers to the meaning of quick opening control valve. What do you mean by quick opening? Quick opening means if you rotate the stem position in a small percentage, for example, 30%, you open 30% position, but the flow is 90%. Quick opening means for sudden changes in the stem position, you can expect maximum output flow. It is also called sensitivity. So for quick opening, it has having maximum sensitivity. అంటే నువ్వు కంట్రోల్ని చిన్నగా టచ్ చేసావు అనుకో, చిన్నగా ఓపెన్ చేసావు అనుకో, నీకు ఫ్లో ఎక్కువ వచ్చేస్తుంది అన్నమాట. దట్ ఈస్ కాల్డ్ క్విక్ ఓపెనింగ్. Understand? Next one is linear. Next one is linear control valve. What is linear control valve? Linear control valve can be understood by knowing the characteristics of the control valve. See the second graph. On the same graph sheet, you observe the straight line passing through origin. The second graph is nothing but linear control valve characteristics. What it means? It means that based upon the stem position, you may expect the flow rate. In the previous case, what happened? For sudden changes in the stem position, expecting large output, large flow. That is called quick opening. But in this stem, it's not like this. If you increase linearly stem position, you may expect linear flow output. So the relation between stem position and flow rate is always linear. You enter open cheste ante vastadi water. That is the meaning of this. And the last one is equal percentage control wall. Equal percentage control wall. The meaning of this is, see the observe the graph. Observe the graph. So the third graph on the same graph sheet, the third graph. See. So that the graph refers to non-linear shape. Non-linear shape.
సార్ స్క్రీన్ షేర్ అవ్వట్లేదు అనుకుంటా సార్, ఏం కనిపించట్లేదు.
Not understand ma? Not
నాట్ విజిబుల్ సార్.
now it is okay. Amma Kohli, now it is okay. Hello? Is it okay now?
ఎస్ సార్, ఎస్ సార్.
And ఇంతవరకు రాలేదమ్మా?
లేదు సార్, ఇప్పటి వరకు రాలేదు సార్. మెసేజ్ చేశాను సార్.
Oh, okay. Sorry, ma. Yeah, I listen. So control valve is a device. Control valve is a device that regulates flow of liquid, or fluid, or gases, or any fluidized solids or slurries, vapors. So with this control valve, we can control all these. How do you control? By opening or closing. Sometimes by partially obstructing various passages. So this is nothing but a control valve, right? So there are three types of control valves: quick opening, linear, equal percentage. What is quick opening? Quick opening means, see the graph. See this graph. In this graph, see the first graph. This total graph is drawn between stem position and flow rate. So stem position is available in the control valve. Based upon the stem position, there exists flow rate. అంటే వాల్ పొజిషన్ బట్టి, అంటే స్టెమ్ పొజిషన్ బట్టి మనకు ఫ్లో వస్తుంది బయటకు. సో గ్రాఫ్ ఎలా ఉంటుందంటే దాని రిలేషన్, ఇఫ్ యూ కీప్ ఓపెనింగ్ మీన్స్ for 30% of stem position, 30% of stem position, you can expect 90% of the flow rate. 90% of the flow rate. So that is the meaning of quick opening. Quick opening means sudden output, sudden maximum output. That is the meaning of this. Quick opening refers to sudden maximum outputs. That is based on the position of the stem. That type of control valves we have to place as per our requirements with the process industries. అన్నీ ఎలా ఉంటాయని చెప్పను, అంటే మనకు అవైలబుల్ బట్టి, మన అవసరాన్ని బట్టి అట్లాంటి కంట్రోల్ వాల్స్ యూజ్ చేసుకోవాలి. ఏమవుతుంది, దీంట్లో తక్కువ ఒక 30% ఓపెన్ చేసాం అనుకో, 90% అవుట్పుట్ వచ్చేస్తుంది. సెన్సిటివిటీ ఇస్ వెరీ హై ఇన్ దిస్ quick opening control valve. See the graph. What a curve maximum output. See 0, 0.2, 0.4, 0.6, 0.8, 1. So when the stem position is 0.3, what is the output? Output is 90%. See, this type of characteristics provided by the control valve, nothing but quick opening. But the second one is linear control valve. Linear control valve means the relation between stem position and flow rate. Is always linear. Linear refers to how much change in position, the same change you can expect in the flow rate. Linear change, stem change 0.1, output change 0.1. Stem change 0.2, output change 0.2. Stem change 0.4, output flow also 0.4. That is the relation between stem position and flow rate in the case of linear control valve. So the graph is always a straight line passing through origin. That type of relation is available in the linear control valve. Okay, and lastly, equal percentage control valve. Equal percentage control valve, nothing but the word says that equal percentage. Equal percentage, see the graph, the relation between stem position and flow rate is non-linear. Is a non-linear. Looks like a parabola, like a parabola. Non-linear, highly non-linear characteristics. So, how much percentage stem position is changed? How much percentage of stem position is changed? That and how much that same percentage of flow rate is also be changed in the output side. But remember, it is not linear. It is not linear. Percentage of change stem position, if it is exists, there also percentage of change of flow rate exists. That relation percentage of change exists between stem position and flow rate. That relation is available in the equal percentage control valve. So how can you understand graphically? That is understand analyze with the graph drawn between stem position and flow rate. See, it is a non-linear graph. At any position of stem position, you can expect how much flow rate is available. This type of graphs characteristics provided in the equal percentage control valve. Okay, and apart from these three control valves, we can also have in different control valves. These are not available. Of course, you can study, but it is not available in the syllabus. The three is enough for the essay question, right? And see, what are the different types of controllers available in the process industries? You can take any chemical plant or any industrial plant or any pneumatic operated devices. You can take. So any case, there should be availability of these control valves, globe shapes. So why is named globe control valve, sliding stem control valve, lifting gate control valve, rotating shaft control valve? Why it named as per the requirement? So how much flow rate we want to control it? Based upon that output flow rate, we need to utilize this, the different shapes of the control. Globe shape, sliding, lifting, rotating shaft, all these control valves you have to use. See, gate valves. Gate valves are used when a straight line flow of fluid and maximum restriction is desired. That means for straight line flow, when the pipe is straight line, and we have to provide minimum restriction in the pipe itself. We have to provide some restriction, minimum restriction, not large restriction. We have to provide that is so called gate type. Gate type. That restriction, nothing but gate. Looks like a gate. And see, this is a graph. See, see the diagram how the gate is provided. Gate wall closed. If you open, see the passage of water. Blue color refers to passage, but no passage available when the gate is closed. Observe the two diagrams. When the gate wall is closed, there exists no passage. But when the gate wall is open, there is a passage. See the passage is looks like blue color, dark blue, dark blue. And see globe wall. This is a globe wall. Different structures of the globe wall. Next, ball walls. These are the ball walls. You can observe this ball wall somewhere, isn't it? చాలా మీరు అబ్జర్వ్ చేస్తారు ఇట్లాంటి షేప్స్ వాల్స్. Okay, ball valves and butterfly valves. Butterfly valves. These are considered butterfly shapes, different shapes. Then, uh, then diaphragm valves. These are comes under diaphragm based valves. Remember, it may be any type. The thing is, why we need to use this control valve? This control valve is basically used for opening or closing the control. I mean, for controlling the fluid or liquid. So what happens when you operate the valve? There exists passage or no passage, or sometimes partial passage. Passages are available for the fluid. And apart from this, very important one is wall sizing. Wall sizing. What is the wall sizing? Wall sizing means, so till now we observe the different control walls, maybe tip opening, linear, equal percentage, globe, or butterfly, or gate walls. All these we are observing. But what do you mean by wall sizing? Sizing refers to, see, through some controller, through some control valve, you can permit a fluid, that means maybe liquid, maybe gas, maybe vapor, isn't it? There are three possibilities you can permit through the control valve. Liquid. For liquid, we want to select one. You want to select one type of control valve. For gases, this is not suitable. We want to select other control valve. And for and for uh, and for and for vapors, these two are not suitable. That means a control valve which is used for liquid, control valve for gases, these two are not suitable. We need to select other control valve for permit in order to permit that vapor, steam, otherwise steam, right? So for based upon the input the liquid or any fluid, isn't it? We need to select a control valve. Control valve sizing refers to, it depends upon, based upon the fluid flow rate, based upon the fluid flow rate. So generally there is a relation between, there is a general relation is the relation between flow rate and velocity of the fluid. Flow rate and velocity of the fluid can be right Q equal to A into V. Q equal to capital Q equals to capital A into V. What is Q? Q is the flow rate. What is A? Area of the pipe. Area of the pipe. What is small v? Flow rate. I mean velocity of the flow. Velocity of the flow. ఎంత velocity fluid వెళ్తా ఉంది అనేది అన్నమాట. And that can be also modified like this. Q equals to some k into root of small del p. మీరు నోట్స్ లో ఇస్తానండి, ఇక్కడ అది ఈక్వేషన్ మిస్ అయింది. Capital Q equals to k into root of del p. Del p. What is k? K is a constant, depends on the valve, depends upon the selection of valve. Q nothing but flow rate. What is del p? Del p nothing but ప్రెజర్ డిఫరెన్స్. ఒక పైప్ తీసుకున్నాం అనుకోండి, ఇట్లా ఇన్పుట్ ఫ్లో వస్తుంది, దానికి కొంచెం ప్రెజర్ ఉంటుంది. మధ్యలో రిస్ట్రిక్షన్ అనుకో ఫ్లో దాని ద్వారా వెళ్తుంది. ఫ్లో బయటకు వెళ్ళిన తర్వాత ఇంకో ప్రెజర్ వస్తుంది, దట్ ఇస్ కాల్డ్ P2. ఇన్పుట్ ఏమో P1, అవుట్పుట్ ఏమో P2, మధ్యలో రిస్ట్రిక్షన్. సో డెల్ P refers to pressure difference between P2 and P1 minus P2 అదనమాట. సో what is the equation for this control valve? Flow rate and pressure difference equation is capital Q equals to k into root of del p. K into root of del p. What is k? K depends upon the selection of the control valve sizing. Why we need to select the control valve, because if the inlet is water, we have to use some structure of the control valve. డయామీటర్ ఎంత ఉండాలా, ఏరియా ఎంత ఉండాలా, స్టెమ్ లెంత్ ఎంత ఉండాలా, పొజిషన్ ఎంత ఎంత ఆపరేట్ కావాలా, అలాగన్నమాట. ఇఫ్ ద అదర్ అపార్ట్ ఫ్రమ్ దిస్ వాటర్, ఇఫ్ ఇట్ ఈస్ గ్యాస్ అనుకోండి, గ్యాస్ ఉన్నప్పుడు ఎట్లాంటి స్ట్రక్చర్ ఉండాలి కంట్రోల్ వాళ్ళు, ద స్ట్రక్చర్ ఇస్ డిఫరెంట్. అలాగే ఇఫ్ యు అప్లై స్టీమ్ వేపర్ యాజ్ ఇన్పుట్, వాట్ ఈస్ ద స్ట్రక్చర్ ఆఫ్ కంట్రోల్ వాల్? If input is modified, the control valves are should be modified. So one thing we can get, for any input, what is the basic relation for all these inputs? If it is water, if it is gas, if it is steam, what should be the relation, the corresponding relation between Q and pressure, flow rate and pressure? What should be the general relation? The general relation can be write capital Q equals to some Q into some K into some K is replaced by capital C root of del P by capital S. Q equals to C into root of del P by capital S. What is Q? Flow rate. What is del P? Input and pressure difference, input pressure and output pressure. Fine. And what is C? C is some wall flow coefficient. Wall flow coefficient. I will tell you what is the meaning of this. Wall flow coefficient. What is S? S nothing but specific gravity of the liquid. So by considering wall flow and specific gravity, pressures, then we can decide the flow rate. Right? We can decide the flow rate. Here I am missing the equation. I will give the note, no problem. Right? And then if the wall size is suppose half inch, you are speaking wall size half inch, 1/4 inch, 1/2 inch, 2 inch pipe, isn't it? You are speaking like this. What is inch refers to? 1/4 inch, 1/2 inch, half inch, 1 inch, 1.5 inch, 2 inch. What is this refers to? The inch refers to wall sizing. For half inch, what is the C value? What is the C value? For 1 inch, what is the C value? For 1.5 inch, what is the C value? So we want to select all these C values before going to design this control valve. Is a designing factor. Okay. So that's about wall sizing. Wall sizing, strictly speaking, what type of input we are applying, what you are going to permit through the control valve, that depends upon the sizing. You select, if it is liquid, you select the inch of the control valve. If it is gas, you select other inch of the control valve. If it is vapor, you select other inch of the control valve. That's the meaning of it. You select different valve sizings for different allowable the fluid. So that depends upon the flow rate and other specific gravity of the input what we are allowing. This is about control valve sizing. Okay. Then in the manufacturing process, generally, if you observe any steel plant, so it is a continuous process. That means what happens, any raw material, gravel is given to some system, gravel is converted to some other iron, that iron converted to steel, that steel into shaped other shape of the suitable sizes and thickness of the steels is a continuous process. So in the steel plant, the output is steel, but the input is a gravel. Input is gravel. So if you, for any steel plant, if you apply a gravel as input, it is a continuous process. Continuous process. So ultimately you can expect steel as output. So in the manufacturing process, there are two processes are going on. In the manufacturing process, there are two processes are going on. One is batch process, one more is continuous process. Continuous process means, see, industrial process that continuously receives raw materials and process them through to complete units, to completed units. That means raw material means a gravel, completed units means steel. Nothing but steel. This what continuous process nothing but is a continuous process in order to get a final product. Final product, for example, steel from steel industry, is a continuous process. But it is a different from batch process. What is batch process? It doesn't accept continuous inputs. It doesn't accept continuous inputs. It accepts input and process it, you may get the final product. Final product. That is called batch process. See that a process that is not in continuous or mass production or mass production. Operations are carried out with discrete quantities of material or a limited number of items. Limited number of items. అంటే ప్రాసెస్ రెండు రకాలు ఉంటాయి. కంటిన్యూగా ఉంటుంది అంటే అవుట్పుట్ రావాలంటే కొన్ని ఇన్పుట్ తీసుకున్న తర్వాత ఆ ఇన్పుట్ మీద పని చేస్తూ మనకు ప్రొడక్ట్ ఇస్తాయి. దట్స్ కాల్డ్ బ్యాచ్ ప్రాసెస్. Batch processes. Okay, these two processes are happening in the manufacturing process. Okay, I don't know whether you are satisfied with this or not. Understand the meaning of control valve. Understand the meaning of control valve. Control valve. Control valve simply controls the liquid flow rate, the fluid flow rate. Fluid flow rate. How it is going to be controlled? Based upon the stem position. Stem position. Stem position. Okay? Okay. And see